everyone, this video would focus on conic section, specifically on ellipse with center at HK, and this is the fifth part. In this part, we're supposed to determine the standard equation of an ellipse, and we're supposed to sketch the graph of it. We are given the coordinates of the two foci and the coordinates of the two co-vertices. Before we go over this example, let's have a review on the parts of an ellipse and the two cases of an ellipse with center at HK. Please remember that these are the parts of every ellipse. The first part is the center. For this case right here, this is not at the point of origin. Our center is at HK. This coordinate HK is the reading along the x-axis that is represented as the H, and the reading on the y-axis is represented as the K. Please remember that the center is the midpoint of the major axis. It's also the midpoint of the minor axis, and it's also the midpoint of the foci, the two foci. Another part is the major axis. The major axis is the longer diameter. This is the line segment that connects the two vertices passing through the center. So on both ends of the major axis is the vertex. A vertex is the end point of the major axis, and there are two of them. So we call them as vertices. Another part is the minor axis. The minor axis is a line segment that connects the two co-vertices passing through the center. So the end points of the minor axis is a co-vertex, and there's going to be two of them. We call them as the co-vertices. So by definition, a co-vertex is the endpoint of the minor axis. And again, there are two of them. Another part is the focus. We remember that the coordinate of the focus for this case, which is the horizontal ellipse, is represented as H plus minus C comma K. So this is the coordinate of the focus, again, for the horizontal ellipse. We remember that the distance from the center to the vertex is represented as letter A, while the distance from the center to the co-vertex is represented as letter B, and the distance from the center to the focus is represented as letter C. We also remember that the formula for a horizontal ellipse is represented as quantity x minus h squared over a squared plus quantity y minus k squared over b squared equals 1. Now, please notice that the value of a is under the quantity x minus h squared. The reason for this is because it is a horizontal ellipse. Horizontal means left and right, so the A will be under the X. Now, we also remember that the value for A is always greater than B. And the equation that relates A, B, and C is C squared equals A squared minus B squared. Now, let's look at the second case of an ellipse. The second case of an ellipse is the vertical ellipse. We pretty much have the same parts. We have the center. We also have the major axis. We have the two vertices. We also have the minor axis. We have the two co-vertices. We also have the two foci. Now we remember that the coordinate for the focus of a horizontal ellipse is H comma K plus minus C. Now we also remember that the distance from the center to the vertex is represented as letter A. The distance from the center to the co-vertex is letter B. And the distance from the center to the focus is represented as letter C. Using all these values, we remember that the formula for vertical ellipse is quantity x minus h squared over b squared plus quantity y minus k squared over a squared equals 1. Now we remember that our a squared, which is the greater value, is placed under quantity y minus k squared. The reason for that is it's because this is a vertical ellipse. We remember vertical, that means it's up or down. And so this is placed under the y. And we also remember that a is always greater than b. And the formula that relates these lengths A, B, and C is C squared equals A squared minus B squared. So these are the parts of every ellipse, and these are the two cases of every ellipse, the vertical and the horizontal ellipse. Okay, going back to the problem right here, we are given the coordinates of the two foci, that is -5. So I'm going to change this into its decimal version. That would be -5, and this 2 plus 2 squared of 10, if you use the calculator for that, this is 8.32. And we also have here, this is -5. And if we change this to its decimal version, 2 minus 2 squared of 10 is -4.32. And then we also have the coordinates of the co-vertices and the coordinates of the other co-vertex. So that we can go ahead and plot these 4 points on this coordinate plane right here. Okay, now we remember that the center of an ellipse is the midpoint between the two vertices, or the midpoint between the two co-vertices, or the midpoint between the two foci. So the midpoint between these two foci and these two co-vertices is this point right here. Again, you can use the midpoint formula to determine this dot right here, or you can just go ahead and count it. If we count the distance between the two co-vertices, 1, 2, 3, 4, 5, 6, divided by 2, that's 3. So we go 1, 2, 3. That's where the center is. I'm going to label this as the center right there. So we can go ahead and say that our center is located on -5, 2. And since the two foci here are vertical relative to each other, we can go ahead and say that this is an example of a vertical ellipse. So I'm going to go ahead and write that information up here. Since this is an example of a vertical ellipse, the general equation for a vertical ellipse is x minus h squared over b squared plus y minus k squared over a squared equals 1. Now notice that our a squared is under the y squared. It's because this is a vertical ellipse. So we're going to determine the values for a and b. We already have the center. This represents the hk. So we can plug that in here, but we wanted to determine the b and the a. Now we remember that the distance from the center to the vertex is our A, while the distance from the center to the co-vertex is B. We don't have the vertex in this picture that we have here, but we have the co-vertex 1, 2, 3. Again, the distance from the center to the co-vertex is represented as letter B, so I can go ahead and write B is plus minus 3. This tells us that our B squared is 9 because the distance is 1, 2, 3. And so we can go ahead and plug this B squared into this, so the equation would come out. X, we are going to switch, so that would be a -5, so I write plus 5 squared over our B squared is 9. Plus, we have a y switch, that's a positive 2, so it's going to be a -2 squared over a squared is missing. I will keep that blank, and that is equal to 1. Now, we have here the value for C. C, again, is the distance from the center to the focus. Now, we have the coordinate of the two foci here. Since this is a vertical ellipse, we remember that this coordinate of the first focus is h, k plus c. And this other coordinate here is h, k minus c. This tells us that this is our value for c. That's going to be a plus minus 2 square root of 10. So if you notice, we have 8 h and k, and then we have h and k, and on the k we have to add the value for c. So our c then is that's gonna be plus minus 2 square root of 10. You can use the distance formula as well to determine the distance between these 2 points, but that is the fastest way to determine the c. Since we have a c, we can therefore go ahead and determine the value for a using the equation c squared is equal to a squared minus b squared. So I'm going to go ahead and show that work up here. Since we have a c, I'm going to plug it in. So that would be 2 square root of 10 squared equals our a squared is missing. That's what we're looking for so that we can put in the value here. And that is minus the b squared is 9. Now, if we have 2 square root of 10 squared, 2 squared is 4. So I'm going to write 4 times square root of 10 squared is just 10, so I'm going to write 10, and that is equal to a squared minus 9. So this is 40 equals a squared minus 9. We wanted the a by itself, so we're going to add 9 to both sides, plus 9 and plus 9. So then we can go ahead and say that our a squared is 49. So I'm going to write that down here. This tells us that our a then is plus minus 7, because you have a square root of 49 is 7. This tells us that we are going to go up 7 and down 7 to determine the vertex. So 1, 2, 3, 4, 5, 6, 7. This is the first vertex. By the way, this focus that we have right here is supposed to be negative 5 and 8.32. So that would be 5, 6, 7, 8.32. That should be somewhere around here. And so we can go ahead and sketch the ellipse. This tells us that our a squared is 49. So I'm going to put that down here. So this is the equation of this problem that we have up there. Now, if we look at the coordinates of these two vertices, we can go ahead and write it down here. Okay, moreover, we can go ahead and determine the length of the major axis and the length of the minor axis. I'm going to write it down here. So this is the equation for this problem that we have here, and this is the graph of this equation. Now let's move on to the next example. At this time, I would encourage you to pause this video and try this problem out on your own. And when you're done, unpause it and check your answer. Okay, so we go over the problem here. So we are going to change this coordinate negative 1 minus 2 square root of 7 to its decimal version, and this negative 1 plus 2 square root of 7 to its decimal version. And this is how it's going to look like. Okay, so I plotted these 4 points right here. So these are the two foci and these are the two co-vertices. Now we remember that the center of an ellipse is the midpoint between the two vertices, or the midpoint between the two co-vertices, or the midpoint between the two foci. So looking at this, our center is located here. So this is the midpoint between the two co-vertices and the midpoint between the two foci. So this is our center. So we can therefore say that the coordinate of the center is negative 1, negative 3. And this is an example of a horizontal ellipse because the two foci are horizontal relative to each other. So that we can go ahead and write that information up here. Since this is the horizontal ellipse, our a squared is under the x. So we already have a value for h and k because the center is represented by hk. So we need to determine the value for a and b. Now we remember that the value for b is the distance from the center to the co-vertex. So in this case right here, we have 1, 2, 3, 4, 5, 6. So our b is plus minus 6. This tells us that our b squared is 36. So we already have a b squared, we have the h, and we have the k. Now we need to determine the a. A is the distance from the center to the vertex, but we don't have the coordinate of the vertex, but we have the distance from the center to the focus. Now we remember that since this is a horizontal ellipse, this coordinate of the focus here is represented as h minus c, comma, k, and h plus c, comma, k. So this tells us that this is actually our C. So I'm going to go ahead and label that down here. So this part right here is our C. So notice that is H and K. H and K. But we added the C to the H. So we go ahead and say that our C value is gonna be plus minus 2 square root of 7. So that value right there. So we can go ahead and solve for b squared using the formula c squared equals a squared minus b squared. So I'm going to show the work down here. So we already have a value for a squared and b squared. So this equation will come out. That's going to be x. Remember, this is switched. That's a -1. So that's a plus 1 squared over our a squared is 64. Plus, that's going to be y. We switch. So this becomes a plus 3 squared over the b squared is 36 equals 1. This is the equation for this problem that we have up there. Now, we remember that our A here is the distance from the center to the vertex. So that means we count 8 steps to the left and 8 steps to the right to determine the location of the two vertices. So these are the coordinates of these two vertices. Now let's determine the length of the major axis and the length of the minor axis. So if we counted, the length from vertex to vertex would be 16, and the length from the co-vertex to the co-vertex would be 12. Did you get the same answers as this? Good. Perfect. If you find this video helpful, hit like and subscribe for more math videos. See ya!